Alright, so in this video we're going to talk about the second derivative test. So the second derivative test classifies critical points as local or relative extrema. So let's consider a point x equals a, where the derivative at a equals 0. That's what it means to be a critical point. All right, so if the second derivative at a is positive, then f of a is a relative minimum. Conceptually, you can see why this is the case. Say we have a function and it has a second derivative that's positive, so it's concave up, and it has a slope of 0. It's a critical point. That point must be a relative min. Second part of the second derivative test, if the second derivative is negative, less than 0, then f of a is a relative maximum. Again, we can see why this is the case. We have concave down, slope of 0, that's going to be a relative maximum. And then the third part says if the second derivative is 0, the test is inconclusive. We don't know. All right, so let's do an example. So let's consider the function g of x defined as 5x cubed minus 10x squared. And let's find its critical points. And classify them with the second derivative test. All right, so first derivative by the power rule is going to be 15x squared minus 20x. If we set this first derivative equal to 0 and factor out 5x, leaving behind 3x minus 4, we'll get our two critical points. We'll get x equals 0 and x equals 4/3. So those are our critical points. And now we want to take these critical points and put them into the second derivative. So let's compute the second derivative. The second derivative is 30x minus 20 by the power rule. And if we put 0 into this second derivative, we'll get 30 times 0 minus 20, which is negative 20, which is less than 0, so negative. So this means that g of 0 is a relative maximum. Relative maximum. If we put 4/3 into the second derivative, we'll get 30 times 4/3 minus 20, so that's 40 minus 20, which is positive 20. And this means that g of 4/3 is a relative minimum. If we sketch this function, we can see why this is the correct result. So you can see we have a local max at 0 and a local min at 4/3. All right, I hope you found this video useful.